Oh,
Are we going?
Yeah, we're
this is
good.
a TA.
I'm here.
So they're a team,
Yeah.
so we're going to talk about the Verilog, or the new file. So essentially, this is like the state machine where we initialize everything, get our input, and shift count is all set to 0 because we haven't shifted anything yet. Then shift buffer, it takes in and stores an 8-bit value from the new bit stream, and then as we keep reading in, once those bits are read in, shift buffer keeps incrementing to see what the next bit is. Count bits will increment if it sees consecutive bits, and so will bit count as well. And then once the shift buffer reaches the end of the first in, first out buffer, it'll get in 8 new bits from the new stream. Bit count will be reset to 0 so that it can, count bits will be reset to 0, and bit count will keep incrementing if there's more bits that are consecutive. Otherwise, if there's no more bits that are consecutive, it'll switch, be it reset to 0, and then start counting those consecutive bits again. Oh, you're still thinking of doing this? That's essentially the state machine.
Could you explain the general format of run length encoding, how that works?
Run length encoding, basically, so you start at a bit, you see what that bit is. If it's a 1 or a 0, that will be your ID bit. If after that there's another 1 that's consecutive, you start counting how many of there are. So if you get a 1 and then a 0, 1 is your ID bit, and then 0 is after the 23 bits after that, or it's going to be 0 because there's no more 1s, there's only 1. And then if there's 10 ones after that, the first bit's an ID bit, and then the rest of the 23 bits, it'll encode 10, and then that way you know there's a 1, then there's 10 ones after that, and then you keep going after. And that's how compression would work if you have many 1s or 0s in a row.
All right, so how are you interfacing with the new hardware?
Through the other file. So go. So right here.
Alright, so here we start with a flush, just to kind of clear everything out in the beginning. And then we have a while loop. While j is less than pix length, like the number of pixels we're actually going to be loading into the buffer, or the hardware that we just talked about. And also at the same time, while anything else is left, being ready to output from the buffer, just in case anything is left over after we've already gone through every pixel. And here we have to, because we noticed that our bytes were flipped, so I wrote a simple algorithm just to kind of flip all the bytes inside of itself. That way, when it's first in, first out kind of scenario that we had to kind of fix. Then this here's where we actually output. We send a flag saying we're ready to actually output data to the hardware. Pass it that byte we just flipped, and then send a flag saying we're done sending. And this continues while the buffer keeps going while it's not full. Then when it is full, it'll pause, and in the meantime, if we're also checking at the same time if we're ready to receive anything back from the buffer. If it'll send a flag. When it's true, we'll send a flag saying we're about to receive something from the buffer. We'll pull out our new array, very compress, and then they'll send another flag saying we're done. At the very end, after we're out of the while loop, we'll flush again to get any remaining data that's left over, and then we'll do the same thing again. We'll send a flag saying we're ready to receive. We'll actually receive the data, and then we'll send a flag saying we're done. That's how we work with the hardware.
Okay, so how do you do decompression once you've put the data in that format?
Right, so then after the data is sent between the two boards, we come over into our master. And the master is what handles the decompression. So right here. So basically what we do is first packet we receive, because after that it's broken up into 3 bytes, so that in order to be transmitted. So we have groups of 3 that are coming in. So of the first byte, we look at the very first bit, that's our ID bit, and then from there we calculate the length by adding up the next 7 bits plus the other 2 bytes that just came in. That gives us our ID bit and our length in order to run RLE, so we know how to reverse the RLE. And then from there we can, Pete, who's not here unfortunately, wrote a really nice decompression algorithm that kind of will increment the number of bits from 0 to how many bits there are after, but and then every time num bit hits 8, it'll increment a new byte. That way it just kind of avoids, so it doesn't matter where we leave off in each byte, we always just kind of know where the next bit's gonna land, even if there's leftovers. And that's pretty much it. He just shifts in, so we just do with the previous byte, add it with the next byte, shift it over. I'm not exact, yeah, that's what it.
So can you show sending an image over?
Yeah, so that's gonna take, we'll like fast forward that part. So we already have a picture loaded into Flash. So we're just cut it now.
Yeah, we're gonna have to.
So, should I just stop it?
Yeah, it's gonna take a while.
I could.
All right. So can you bring up your top level design file? Show me how you added the new hardware.
Is it this one?
So that's just the buffers. You're gonna want the D2 net.
Oh, D2.
It's not the right folder. What file is it?
Which file was it?
I don't remember.
I thought it was in this one that we added though then.
Yeah.
Oh.
Wait, no, you skip it. Wait.
That was like the first thing we did.
Yeah, this is like
All right, so
10 days
how
ago.
did you add your new hardware?
How do we add the new hardware?
Yeah.
So here we added the new wires and everything. I'm not really sure how to talk about
We
this.
followed the video.
What?
Yeah, we followed the video and explained like what.
Yeah.
Basically, we have new hardware, so we had to kind of build the wires to go between each piece of hardware, and where all the flags and all like the data transfers will actually be handled between
What things are the wires actually between?
the FIFO received, the actual RLE unit, and the FIFO transmit back to the in between the NIOS. So the NIOS talks to the receive and the transmit back.
All right. Where do you instantiate these?
We define them here, like with all the inputs and outputs.
Can you explain like what an example line inside of the instantiation means?
Well, it sets like the clock, like it defines the clocks inside, and I don't really know. Really know.
Repeat here.
All right. So that defines the inputs and outputs and the wires that they're connected to.
Yeah.
Did you add anything to the system core module?
SOPC builder? Yeah, in
And
here.
also within this file?
Could we add something new?
What?
The system core module.
Yeah. You added some things.
Over here.
No, within D2.v. The system core Verilog has some things that you added to it. If you go down, yep, that's your main core, and you added some things to that. At the
Oh,
end,
down here. The import too.
yeah. So
Um,
those are for
These are the commands we actually use to
yeah.
communicate with the hardware. Import and output. It's like what we showed in our actual C code.
so those are the connections.
Yeah, right. This is what we actually address to flag and send data and receive data back from the hardware.
All right. Do we have images going up?
Oh yeah. Oh no, shit. We weren't even transmitting the whole time. Nope, we don't.
Get image.
Yeah. So we already have an image stored on Flash.
You want to give it to me? I'll take the video of it.
Yeah, it's not, dude. Look at, it's not communicating with us right now.
Really? Rerun it. That's what we have to do.
Flash.
All right, so we got the image.
Load it into Flash
Load
right
it into
now.
Flash
And now we're gonna start transporting.
from slave, and now we're gonna start transporting.
So not sending one packet at a time.
I was sending packets and gonna assemble them.
I don't think I have to hold it for 33 packets. Might get
No,
a
I'm
little
not.
tired.
I'm just gonna let it like show 2 packets assembled and stop it. And it's done.
Busting 4 minutes.
Let's go. All the packets are assembled. We're gonna do this. About to display the image.
I don't know why. Every group that I've seen
Wait.
has it now.
And bam. The image is displaying.
That was transmitted, decompressed. I think that's for the show.
I don't remember what I had you. Did you guys talk about your decompression algorithm?
Yeah, we talked about everything.
All right.
And good.
We went over the Verilog. We went over.
We went over the wiring. We went over decompression. We went
ROE.
over how we talk to the
and
hardware and
C
software.
interfacing.
Yep.
Yep.
Yeah. All right.
Sweet.
Good.
Thank you.
Thank you.